So, hello everyone. Hi, yeah. I'm getting over jet lag. You all had to travel about an hour, so I mean, yeah. So this is going to be a talk about the lightweight render pipeline. If you're in the wrong room, then please stay. There'll be more British jokes than wherever else you go. So this talk's about 45 minutes long, and I'm going to be giving a general getting started overview of the lightweight render pipeline. There'll be a little bit of code, so anyone who's an artist, don't be afraid and start crying. Anyone who's an artist, anyone who's a programmer, don't be afraid if there's a little bit of art. And we'll have some fun. So my name's Andy. I work at Unity Technologies, based in the Copenhagen office in very cold Denmark. And I'm basically a global content evangelist. My family still has no idea what that is, nor do I. No, so I build a lot of demos and work with R&D directly, and then come and teach people how to use Unity and use new features and things like that. So if you see me wandering around, just come up and say hi. We'll talk about shaders, lightweight render pipeline, 2D stuff, England, pots of tea, all the typical stuff people think I like talking about. And I'm also on Twitter, as everyone is. It's just my name without a space bar, without a space. So I just post all sorts of weird shader stuff on there if you want to see that. Cool. So one big question a lot of people ask when we talk about lightweight render pipeline on HD render pipeline is what actually is a scriptable render pipeline? You've probably heard scriptable render pipeline, or SRP, mentioned quite a lot. So this is a big question a lot of people ask me. So the general consensus is that it's a way of configuring and performing rendering in Unity that is controlled from C#. So what we're doing is we're basically taking the render pipeline of how games and content and projects in Unity are rendered, and we're basically exposing this up. So you can read it, dissect it. It's less of a black box. So this is a screenshot of the current built-in renderer in Unity. So you have forward and deferred shading and rendering, with various stages where the image on the screen is drawn, from lighting to depth texture to opaque objects to transparency and things like that. And beforehand, a lot of people complained because they were like, we don't really know how the image is being rendered in Unity. And of course, you're writing shaders, and you're writing image effects, and you're doing all sorts of exotic stuff. Like, you want your projects to look the way you want them to look. And sometimes you're sort of scratching, I've done it as well, scratching your head, and you're not sure why something's being drawn and why it's not, or how you can customize it. So we're making Unity's rendering less of a black box. We're opening and exposing different things. We're allowing you to have more choice in how a game or project is rendered. We're allowing more customization via exposed methods and parameters, and I'll show you some of those today. And we're allowing more control over how and where performance resources are used. So the scriptable render pipeline is currently optional. So when you boot up a new Unity project today, by default, it uses the built-in renderer. It's the one that's been around for a long time with forward and deferred renderer paths. And it's default today. And we've used it to create pretty much all of our demo projects, like Adam and things like that. But with this new dawn of the scriptable render pipeline API, what we're doing is we're offering an API and a core set of libraries and shaders and things. And we're using that ourselves to make 2 render pipelines as examples for people to use. But we're also sharing the render pipeline API so people can create their own render pipelines if they want to. So these are kind of opt-in currently. The 2 render pipelines that we're actually working on internally at Unity currently is the HD render pipeline, which you've probably seen if you've seen the Book of the Dead Forest demo. And at the keynote tonight, I don't mean to spoil it, so put your fingers in your ears if you don't want to hear it. Like, you're going to see some really cool stuff tonight. And the other one we're working on is the lightweight render pipeline. And they're being made for 2 different reasons. One is the HD render pipelines to add more high-end fidelity graphics tools and features, such as lighting and decal system, finally, and all these different things. And the lightweight render pipeline is kind of going down the other end of the scale. It's focusing more on optimization and more stripped-back renderer. And the lightweight render pipeline is going to be a good entry point for graphics programs to start to dissect how a render pipeline is, or how a script render pipeline is made, and how to customize it and things like that. And then, of course, there's the custom render pipelines, which some people have made. So there's a guy called Kajiro, which some of you have probably seen his GitHub. He's done like a retro render pipeline and all sorts of really cool stuff. I'm going to be talking about this one. We have plenty of talks about the others, so I figured I'll talk about the one thing we should probably talk about more, which is the lightweight render pipeline. So as a disclaimer, the lightweight render pipeline is currently in preview, and it's aimed to leave preview sometime early next year. And the information in this talk is as of 2018.3 and this lightweight rendering package. And the reason why I'm putting this up here, so when people watch the video later, they always use older versions and then send me an email getting really angry and stuff. So this is why this is here. But all the demos and things I'm going to show is available today, and you can do today. So I'm not showing any custom magical stuff that's like, 2021 is when you can do this. Everything is using public stuff today. We also have a current limitations and roadmap forum thread on the graphics forums. So if you want to see like current limitations or what it can't do and when things are aimed for in 19.1, 19.2, I highly recommend going to that. And I've got a link to I've got all the links in a slide at the end for you to take a photo of for reference. So at a high level, the lightweight render pipeline is a stripped-back optimized rendering pipeline focused on performance and targeting mobile and XR. But it's also capable for pretty much every other platform like console and things like that. It's a single pass forward renderer. It does single pass forward rendering, and it's optimized in consistent PBR. Like I'm sure some of you have used like standard shader and lights, and then you build a mobile, it looks completely different. You're like, why is it doing this? So it's been made to be more consistent. We have a whole new stack of new shader libraries. So rather than a massive CGINK file, which has all these crazy references, they're a lot more broken down into individual parts. So you can kind of see this is the shadow section, this is the light section, this is the main directional light section. It's more current, more modern. And one of the benefits is you can combine real-time lights in a single pass. So you can have lots of like point lights and things flying around, all combined into a single pass. And I have some examples later. And there's also an API, and this is hot out the oven like as of like 3 weeks ago or something, to inject scriptable render passes. So in the rendering process, you can say, after the opaque pass, inject a custom render pass to do something with that opaque data. So you can kind of customize the renderer without modifying the source code, which is super cool, because you'll modify the source, and then we update it, and things happen. The source is actually in C#, and it's entirely on GitHub right now. You can go in, download it, modify it, break it, learn from it, add things. Rendering is less of a black box. You can literally step through and see what is being drawn and when, so the render process is readable. And the reason why we're making it C# or making it publicly available, both lightweight render pipeline and HD render pipeline, is so people can modify it, so they can tweak things, they can add features if they want to. So a user added like real-time SSAO and things like this. You can also remove stuff, like if you don't want lighting, you can just remove lighting if you want, and you can also learn from it. So we've had a lot of graphics programmers come and say, this is really useful to read how a render pipeline is set up. Like, I've written shaders and image effects and things. I want to know how a renderer actually like could be implemented. So that's why we're doing it. We made a couple of demos and showed them. So at GDC 2018 in March, we showed this last stand demo, which is kind of, I guess, like a Left 4 Dead type thing. So this was using the lightweight render pipeline. So it has like all the typical things you'd expect from a render pipeline. We have this new project called Boat Attack, and this is a lightweight render pipeline demo project made by one guy. And basically, you can download it as well from GitHub, and I'll have some links later on. And this is a demo that's been created purely to show how you can do different things like custom render passes or shaders and things like this. Oh, don't worry about the audio. So for example, you have all this really nice, pretty water. This is all, oh, these boats are crazy. It's supposed to follow that boat, but now, oh, yep, please go. All right, anyway, I'll just go into scene view and fly around. So you've got like these windsurfers, and you've got wake, and you've got like new Unity mode of transport, I guess. You have all these pretty cool stuff, like planar reflections and things like this. So this is a project that you can download, dissect, see how they did planar reflections, see how they did the shaders for lightweight render pipeline. And it's been, oh, you've got these cool like things flying around. So you can, hopefully our boat is, yep. Oh, but the rendering is broken a little. I'll stick to scene view. So you can see how a project is built from the ground up for the lightweight render pipeline. So that's pretty cool. We also have The Trash Dash project, so this was like an endless runner that was made by our, one of our content teams. So they ported it over to the Lightweight Render Pipeline, and they've put it on GitHub as well. And again, I have links towards the end. And actually, most of our shader graph demo projects are actually using Lightweight Render Pipelines, such as this island. We seem to be obsessed with islands at Unity. Maybe we'll have like Unite Hawaii or something next year. It hasn't happened yet, but that would be cool. I'm going to get in trouble. I'm going to get an email from someone saying, what's Unite Hawaii? Like, when is this happening? And oops. So we have this example on the left, which is kind of like using vertex animation shaders created with shader graph. And we also have this lineup thing that this lineup library I've been maintaining of simple shader graphs. So pretty much all our shader graph demos have pretty much been made in Lightweight Render Pipeline, which is really cool. So you can download those and dissect them and learn from them. And I've got a bit more about shader graph later on in the talk. So now is demo time, how to set up a project to actually use the Lightweight Render Pipeline. So I have here a new project. Because we have too many island demos, I'm going to show a dark scientific robot thing. So this is an environment, like a simple robot factory. This is kind of like a sequel to the old Angry Birds demo from like Unity 3 days, if anyone recognizes that, or as old as I am. And here we have a simple character lit by lots of real-time lights. So there's no baked lighting in this scene. So as I go into play mode, I can run around and shoot stuff, and it's affected by shadows and all this stuff. So this is currently rendered in the built-in current renderer. And I purposely, well, sort of purposely, sort of cranked up the stats a little bit. So we've got 1,000 batches, which a lot of that is kind of lights and things, and shadows, a good amount of triangles, set passes, and things like this. So it's kind of not particularly optimized, I'll be honest, and I should really bake lights and things, but I really want to show off how Lightweight handles real-time lights as I switch this project. And if you haven't used it, you should definitely start using the frame debugger. This is going to be incredibly useful when you start using SRPs. So the frame debugger basically gives you a breakdown of all the batches and the order and what is being drawn, and you can then open them up and isolate them individually. So I can go here and sort of cycle through all the different things that are being drawn, and some of you are probably having a heart attack at how unoptimized this thing is, and stuff like this. So the frame debugger is quite useful, but with the built-in renderer, it kind of is a little jumbled and things, and with the frame debugger, it's a lot more organized and neat, so you can actually see what is happening and when. So we have this project here. I've taken a screenshot of these stats, so don't worry about it later on. So to move this project or switch it to use the Lightweight Render Pipeline, you basically get the Lightweight Render Pipeline either from GitHub or from the package manager, or Pac-Man as we call it. Please don't sue me. So when you open up the package manager, you basically have different packages or features you can install. So rather than them being scattered across random forum posts and on Twitter or things, or random Dropbox, we're trying to sort of consolidate a lot of the features into packages and distribute and update them kind of outside the Unity release loop. So we have the Lightweight RP. Sometimes you'll see it called LWRP, but this is called the Lightweight Render Pipeline, which you click and you install. And once it's installed, you can then create a Lightweight Render Pipeline asset. So I'll show you. Sorry, I'm still jet lagged. So this will basically make an asset that you can then create called the Lightweight Render Pipeline asset. And same, if you used HD Render Pipeline, it would use a HD Render Pipeline asset. I've already set up a Lightweight Render Pipeline asset, and it basically looks like this. This is kind of your overview of all the different things that you can, by default, add and toggle and turn on and off in the render pipeline. And a lot of these are actually hooked up to like shader keywords. So for example, if you disable like HDR or lighting and things, they'll actually disable lighting from any shader using that keyword, which is pretty cool. And you basically have this overview of your render settings in one place, rather than scattered across various windows, which it currently is. So let's say we wanted to get the scene to use that render pipeline. So underneath edit and settings, thank God we have a unified settings window now. Like, you no longer have to jump between all these hoops. Underneath the graphics section, we now have this script render pipeline settings option, which is none, means it's using the built-in renderer. But if you use HDRP or Lightweight Render Pipeline, or you make your own custom render pipeline, you basically would assign the render pipeline asset here, telling the renderer to use this system. So let's assign that. When you assign that, everything turns magenta. I knew this would happen. So if you want to target this as your art director said, we would need a magenta game, then you can probably leave this talk and ship a game that looks like this with Bloom. But this is probably not what you want in your game. And you notice that not only is everything magenta, but there's some stuff that isn't magenta, like these little lights along the bottom. So what this is doing is, because it's switching the render pipeline, and because we've actually changed a lot of core shaders and shader libraries and things, some of the older lighting shader libraries are not compatible. However, if you have unlit shaders, those will all work by default. So these lights are using basically the particles additive shader, so that will just work as intended. So normally you'd have to go in and you'd have to go to your materials, and with that package installed, go to the Lightweight Render Pipeline option, and then basically we have different shaders for different purposes. So you'd have to switch them over from one to the other. So if I select a random object, can I even select a random object? So here I've got this metal plating, which is obviously using the standard shader. Oops, shit. Open up. Lightweight Render Pipeline. If I switch this over to lit, it's basically using kind of the Lightweight Render Pipeline's PBR shader. Simple lit is like Blin Phong or simplified, simplified Blin Phong shader. But we also have particles and terrain and unlit and things. So if I actually set this to be lit, and it's here somewhere. Oh, it's this object here. What you'll notice is that the lit Lightweight Render Pipeline lit shader has kind of very similar slots and similar properties or texture inputs and things to the actual standard shader in the current built-in renderer. So when you move things over, a lot of elements will basically can be assigned, like albedo, emission, and things like this. Now, I'm not going to sit here for another 30 minutes and move everything individually. That would be like the worst talk ever, so please don't expect I would ever put you through torture. So instead what we did is we actually made a tool which basically upgrades the project materials, and it will go through and it will get the mappings and basically remap from one to another. So if you have if you're using standard shader and it's using underscore main text or whatever, underscore albedo, it will find the equivalent in the Lightweight Render Pipeline. I've done this once before in my run through, so it's slightly faster than, normally this scene takes 2 seconds or 3 seconds. So proceed. And basically it will go through all the materials and switch them to use the Lightweight Render Pipeline. As you can see, it kind of looks almost similar, but there's a few noticeable changes. One is my batch count. It looks almost identical, and I'll have a comparison screenshot later. You still have real-time lights and all this stuff. Hadn't had to touch post-processing, because that just carries over and things. What you'll notice is that my batches is now basically half. And my verts is kind of 300K less. But the interesting thing is set passes originally were 600, I think, maybe, and now it's 101. I don't know why shadow casters is 0. I think that's a bug. I don't know. But now we have basically the same scene in the Lightweight Render Pipeline with basically similar shader properties, but now it has significantly less batches and things like this. And I'll talk about why in a second. So we can run around, and it looks basically the same. So if I go back to my slides now, I'll sort of show some comparisons and kind of what actually happened. So the left is the built-in renderer, and right is the Lightweight Render Pipeline, or LWRP. So one thing that's very obvious is that on the left, the lights are significantly brighter, or significantly more defined. And on the right, they're a bit dimmer. And that's partly because lights are now physically based and have physically based attenuation and fall-off, as opposed to point lights and things beforehand where you had to increase the range really, really big for it to have some kind of nice fall-off. Now, all the lights by default fall-off is controlled through the intensity instead. So it's basically more physically based light controls. You'll notice that we still have real-time shadows and all sorts of things like this, but lights are just a bit dimmer. And I guess some comparison in screenshots is it's almost half the number of batches because all these point lights. So the scene is using 1 main directional light, 2 point lights, and 2 spotlights are all generally drawn together now, and they're all real time. So rather than them having an extra pass each time per object they're hitting, it's kind of significantly dropped it without us really having to do anything. Triangles are less because of shadows. And yeah, set pass is 401, and now it's down to 98. So just by default, it's basically drawing a lot of things together without actually really having to touch anything, which is pretty cool. So in terms of the lighting, real-time lights are culled per object, but shaded in a single pass. So in this GIF on the right, which one of our graphics guys made, the left is the lightweight render pipeline, and the right is the built-in renderer, basically turning on the same lights. You'll notice that Adam individually is constantly adding each pass one by one by one. I think he's actually just scrubbing through the frame debugger when he recorded this. But on the left, they're kind of all shaded together. So basically, the lights are culled per object as intended, but shaded together. But there is a current limitation per object, and that's one main directional light, like a big fill light, and then 4 additional lights that are both point and spot. They're looking into increasing this in the future, but this is as of today. So that same scene basically uses that one main light, 4 additional lights on there. 16 lights total visible by the camera, but they're also looking at how they can maybe increase that or maybe change that, but that's currently what it is. And lighting attenuation is now physically based, so controlled through intensity, not range. Shaders. So there's new shader libraries. So there's new core shader libraries and lightweight render pipeline shader libraries. And these are split up into smaller chunks. So rather than having one big CJINK file, which includes a lot of methods and includes a lot of things, they're instead split into smaller pieces. And when you actually look through the lightweight shaders, you'll notice they're referencing individual HLSL files. In terms of compatibility, the lightweight render pipeline comes with compatible shaders, but there's no more surface shaders, partly because they were kind of old and the libraries were kind of haven't been updated and things like this. So that's kind of a bit of a downside that we don't have surface shader support anymore. But the benefit here is that Shader Graph will actually generate lightweight render pipeline shaders and code for you. So if you're moving some surface shaders over with albedo, emission, and things, because with Shader Graph we try to make terminology similar, you can actually port a lot of things through Shader Graph visually and then test and then re-export the generated shader code, which I'll show you in a second. And any unlit built-in shaders will actually just render as usual because they're not touched by any lit things. In terms of the lightweight render pipeline source, it's available on GitHub. I've said basically all of this already. But one thing that we've seen a lot of people do is use as a foundation for making your own custom render pipelines. They've taken it and modified it and tweaked it and things like this, like removed all lighting and stuff. And a good entry point, which I'll show you in a second, is this default renderer setup.cs, which is kind of handles all the logic to enqueuing render passes for execution. So this is generally the entry point to understand how the renderer for lightweight render pipeline is drawing the whole frame. And another benefit, and this is really new and hot out the oven, but I'll show you in a demo in a second, is that we have this new scriptable render pass API. So rather than you having the lightweight render pipeline and then you tweak something very slightly and then we update the source and then you're like, oh no, I've now got to merge all the stuff and get your changes, we've added this new API called scriptable render pass, which allows you to capture render states, modify them or do something with shaders or something like this, and then re-inject them into the render pipeline. So for example, you don't need to render a second camera for effects or depth or whatever. You can instead capture these and use command buffers to then execute them. So you can, for example, get all elements drawn in the opaque pass, do something with that, and then re-inject that before the transparent pass even gets there with one camera. So you can do some really cool, clever stuff and dig through the lightweight render pipeline source and learn what you can access and what you can do. John Sietsma, who's basically me, but in Australia, so more Australian. He has a GitHub, and I have a link at the end, which has some examples of some scriptable render passes. One being this kind of frosted glass. So this is taking all the opaque geometry and then applying kind of a blur effect and then re-injecting that into kind of like this frosted wall. The other one is kind of like selective emission. So you can apply a small script on an object and say, just this object glows in post-processing. You can do some really cool stuff with this new scriptable render pass system. And we're working on some more demos in the future. One interesting thing with scriptable render passes, I need to go to that slide, is in this boat demo, they actually use it for the planar reflections. So, okay, it's kind of broken here, but you can see that we have this planar reflection taking place of objects in the distance in the water. So you can download this project and literally lift that scriptable render pass of the planar reflections and like drop it into your project if you want kind of this type of functionality. And it's basically capturing lots of opaque geometry, flipping it, and then reprojecting it into the water shader. So you can do some cool stuff, and there's going to be lots of amazing things on the asset store as people do like colored shadow, real-time colored shadows, and all sorts of amazing stuff with this new scriptable render pass API. So if I go back into this project here, the doom and gloom one, not the nice island one, we can now control and do different things now that we sort of have had a quick run through of the lightweight render pipeline features. One is that the lightweight assets is kind of like the controller of all different things. So if I go to quality and disable, enable HDR, or change the render scale and things like this, so lower the render scale, this is basically enabling and disabling different keywords in the shaders automatically, such as the lit shader. I'm saying actually do no pixel lighting, for example. So there's no pixel lighting. I can switch between pixel and vertex lighting. You can do all sorts of really cool stuff that's all exposed directly into the shaders. So I could actually switch all lighting to use vertex lighting. So you can see it's a lot simpler to calculate, but it's a lot simpler lighting instead. So you can enable that. You can just literally turn off all shadows if you really want to, do stuff like this, and you have a lot of control. And if you go to the HD render pipeline, you've got like a lot more settings like subsurface scattering and all this different stuff. So we're kind of treating these render pipeline assets as kind of like the place where you stop to or add different things if you want to control different elements of your renderer. So now that we have the scene all set up like this, I'm going to open up the frame debugger. So the frame debugger beforehand showed this big camera renderer and then like lots of different things. And what it's now actually doing is it's now split up into different chunks. So if I zoom in here, you'll notice that we can see each of the individual passes that are taking place and the different processes. So it's basically rendering the main shadow map, which is the main directional light, then additional shadows, then opaque geometry, skybox, and things like this. So in the previous built-in renderer, basically it was kind of all jumbled and it's a little bit difficult to navigate, whereas now instead we've got this order from first things being drawn to the last things being drawn. And this is really good because we can then look at specific things such as render post-process effects, go to the lightweight render pipeline source, and find out what's actually happening in that pass. So it's going to be a lot better in actually understanding how your scene is rendered. I'll disable that. I'll come back to you later, frame debugger. So one of the benefits of this is shader graph. So if you've used shader graph, it basically gives you a node-based system to create shaders and construct different visual effects in Unity. So if I open up an example of a shader graph, like, okay, this is literally the simplest shader graph anyone could ever make, so don't judge me. So we have this sort of shader graph interface, which is similar to sort of other shader editors like ShaderForge, where you have different nodes that plug into different things. But the cool thing about shader graph is it will auto-generate shaders for the render pipeline you're targeting. So lightweight render pipeline shaders is what it will spit out in HD and things like this. And the other cool thing, which not a lot of people know about, is if you then copy the shader, and I'm not going to click this because every time I click it, it doesn't work. If I, definitely shaming, someone in the graphics team is going to watch this talk, and yeah, anyway. They'll fix it, hopefully. So if you then copy the shader and then go to your text editor of choice, you then have the generated shader code, including all the properties and names, lightweight render pipeline, things like this. So if you're wanting to learn how to write shaders or what libraries it's using, so here is the keywords it's using. Here is the define. So it's using this shader library core. It's using the lighting and things like this. You notice they're split up into smaller chunks. So if you want to learn, say, how to do a dissolve shader and then modify it, you can actually create that in shader graph, get the generated code, and then optimize or remove things from there if you really want to. So yeah, so we're using shader graph to generate a lot of shader code for people to play with. If I switch over to Google, so I said that it was all in C#, so I'll show you basically where to go and what to look at. So underneath the Unity Technologies GitHub, we have this scriptable render pipeline repository. And inside here, you'll notice that we have the pipeline's core API. So when I said that there's core API and shaders and things like this, and scripts that is found in there. HD, you can literally go into the shader graph and see how the shader graph nodes are created, which is pretty cool. But if you go into the lightweight, not the testing, oh, the testing framework's there if you really want to see it. If you go underneath lightweight, we basically split things into different chunks, like editor, runtime, the shader library, and the shaders. If I go underneath runtime, you'll notice that as opposed to the renderer being kind of hidden and doing some stuff, we've got all the individual passes, all the interfaces, the renderer, even the asset that you assign into the scriptable render pipeline slots is like there, so you can basically go in and toy with it and play with it and see what happens. So if I go to the entry point, or sort of the recommended place to look at, which is the default renderer setup, you can see here that we have all the different passes and different things that are being queued up. So depth only, main shadow, additional lights, and from there you can dig into these individual classes and things. Basically, yeah, you can go through and actually read what order the renderer is going in. So we have the transparent pass, we have the opaque pass, the skybox pass, and all these different things. And you can go in, dissect them, and see what they're actually doing. Super cool. If you go underneath the passes folder, we've then got like the draw skybox pass, for example. So literally how the skybox is being drawn in this render pipeline. So you can go in, tweak and modify. I'm sure people can do all sorts of really weird stuff, as people tend to do with Unity. They make lots of weird things. It's not all weird, it's, yeah. And basically customize or modify this, so how these are executed and stuff like this. So you can go through, have a look, and see what's actually happening. So if I go back into here, now what I'm going to show you is I'm going to show you a thing which is one of those scriptable render passes. So what the scriptable render pass now does, oh, actually, I want to show you a light. So if you now select one of the lights, sorry about this. So let's say this point light here. When I said the lights were basically based off of PBR, so the attenuation is a bit better, by default, when you obviously increase the intensity and lower the range and things, it now has a much nicer fall off than the previous Unity light, which kind of like fell off gradually and just looked a bit weird. Now, because it has more physically based values, I've just found lights by default now just look better, and it's pretty cool. I like making that light really bright, and then, yeah. So, where was I? Oh, custom render pass. So this is kind of one of the big newer things. I was going to show some other shader graph stuff, but I found like there's lots of shader graph information online in blogs and projects and things. So I figured I'll show you something brand new, which I got working last night whilst jet lagged. So let's hope this works. So what the custom render pass allows you to do is it allows you to get a render state, such as all opaque geometry has been drawn or all transparent geometry has been drawn, capture that, do something with it, and then choose where it goes. So you want to billet it to here, do you want to apply it to here, and things like this. That's how the planar reflections are being done in the boat demo. And if I switch back to my slides here, you'll notice here we have these different points to which you can inject this custom render pass into. So for example, you could go to the depth pre-pass, capture all the stuff with the depth, and then do something with that. What I'm going to do is I'm going to take this frosted glass, and after the opaque, inject that directly into shader graph for doing cool screen space effects with no cameras and stuff. Kind of like grad pass, but without actually doing a grad pass. Yeah. So I have a script already written, because if you write it live, things horribly break, as I found before. And what you do is you basically go to your camera, go to this blur grad pass that I've written, and if I set this value, so you notice here that I can actually increase the value, I automatically have something that looks kind of like an image effect. Yeah, this was definitely not a fun demo to make whilst jet lagged, by the way, because my eyes were freaking out. And the weird thing that you can see here is we have this weird frosting effect that's being applied, but you'll notice that the transparent elements here aren't being affected. What's actually happening is that this blur is being applied between the opaque pass and the transparent pass, as opposed to an image effect at the end. And what's even cooler is if I open up the frame debugger, I had a lot of fun with this, writing people's names, we have that custom blur pass literally there. So you know beforehand I showed it without, and it was like opaque, skybox, stuff like this. I literally have the actual render pass that I've injected taking place at that particular point. So if I said, I'll open up the render pass in a second. If I said render this after the skybox, it will actually appear somewhere else. So the cool thing about this is you can not only inject render passes, you can also preview them and see what they're actually doing. So I'll open up the blur and see what it's doing. So it downscales it, it fuzzies it again, and then it re-blits it back to the screen before all the transparent and skybox stuff is rendered. So if I go over and actually have a look at this blur grab pass, let's have a look at it. And I'm sorry, artists, I really am. But this is what, actually this will be good because then you can go to program and say, hey, write me a render pass that captures all the shadows, and then I can do something cool with it in Shader Graph, which I'll show you in a second. So what it's doing is it has a monobehavior class, and it has I after opaque pass. And that might seem familiar, because if I then go back to the Lightweight Render Pipeline source, we have the I after opaque pass that takes place at some point in the stage. So here we go, I after opaque pass. So this is partly the cool thing with the render pipeline being exposed, is you could say, oh, what's actually happening in the skybox? Let's make the skybox, I don't know, have like scrolling matrix text or something. You can go into the skybox pass and then do something with that later on. So that's pretty cool. So if I go here, I after opaque pass, I then have a basic blitz shader and a basic blur shader lifted from that project that John made. So thank you, John, if you're going to watch this later on. Then I have this script render pass, which basically enqueues a render pass, and it feeds in the render texture. So it's capturing things to a render texture, the color handle of the screen, and also the depth. And if you use other things like transparent and skybox, you get some other properties. And then it's passing into that grab pass materials, vector 2s, and things like this, like the blur amount. Now if I go down to script render pass, I have this render pass tag. So this is how it appears in the frame debugger. So someone shout out a name. Has anyone got a name? What was that? Testing. Come on, something more fun. Like oh, yeah. Tack. Tusen tack. Denmark blur pass. Thank you. Yeah, cheers. So here's the Denmark blur pass. That will now appear in the frame debugger as Denmark blur pass. OK, let's go on for Andy's Denmark blur pass. Just some self-marketing. Why not? And then when it finishes compiling, the frame debugger will close and then reopen, because it always does that. Now re-enable it. Let's have a look. Do we have Andy's Denmark pass? Great, there we go. So you can now actually name render passes and see how I had a lot of fun in adding this to people's projects and just having weird names everywhere. So Denmark blur pass, why not? Then in that blur pass, it then gets the information from the mono behavior earlier on. And then it actually then executes the renderer. And you can see you get some information such as the scriptal renderer, the context of the renderer, the rendering data, so if you want to get the depth and stuff like this. And then it basically creates a command buffer with that render pass tag, and then it does a bunch of things. So if you've written image effects or all sorts of different graphics-related things before, some of this is familiar for the blur. It literally copies the screen, gets the opaque elements, sets the filter mode, and then blits it to a screen copy. Then it downscales it for blurring, makes new render textures. It's basically just blitting stuff left, right, center. It's what you saw in the frame debugger as you broke it down. Then applies it to that blur shader, and then I basically re-blit it back to the screen. But when you re-blit it back to the screen, because it's happening after the opaque pass, that's when it's being injected into. So I could set this after the transparent pass, and it'll take place at that point. Now this is OK. Maybe this wouldn't be a very nice sort of custom render pass that you apply to your game. Oh, you also have some glass over here, I think. Where's the glass? Yeah, so this glass here, you notice, isn't really that blurry. It's because it's being drawn after that render pass. So this is OK. People's eyes are probably really hurt. I'm really sorry about this. I know it's early for game developers in the day. So what I'm instead going to do is do something fun, which definitely I didn't get fixed last night, is take this render pass and take that result and inject it into Shader Graph. So this is pretty cool, because then developers can then create custom render passes, and then artists can use Shader Graph to then do something with that render pass. So I'm instead going to comment out that blitz to the screen. Definitely don't uncomment that. And I'm then sending this global texture with this command buffer of _grab blur texture. Yeah, someone was probably like, wow, it just turned into a beach. So that kind of disappears, but if I turn on this big screen display, this screen display is using a shader graph shader to basically project this kind of filter. And you can notice you can still control different things and make things all warped and stuff like this. So it's basically kind of doing a grab pass blur, but it's still injecting that render pass directly to the shader graph shader, which means you now have the power of shader graph to do some nice effects using that result. So here, if you hadn't used shader graph before, you basically have this end master node, which is where the shader outputs things into color and position and stuff like that. And I'm basically taking underscore grab blur texture, what I wrote earlier, last night, and then it's basically applying that out here. Of course, you can now do things. So here I've got a simple kind of almost posterized filter, and then color and tint, and basically you can kind of preview this blur result. So if I now plug this into here and save the asset, I now get this effect, pretty much almost entirely made in shader graph, but now you have like all these sliders and things. So I now have kind of this real-time with one camera kind of custom render pass, which still appears as the Denmark render pass, like so. So the Denmark render pass is actually drawing directly into that screen before the screen is then drawn with the transparent pass. So now you can kind of have real-time weird effects or have real-time different things using render passes. So I can then run the character in and basically have this with one camera drawing things, because if we're already exposing the camera renderer and exposing what's happening in the passes, rather than rendering something to a second camera and then writing a stencil shader for that or doing all this stuff, you can now just have a graphics programmer or someone, hey, I want to get this data. Hey, I now want to feed this into shader graph if I want to, and things like this. So someone give me a different color. Not green or what? Red. Yeah, Virtual Boy. Here we go. I'm not confirming Virtual Boy support. Before anyone asks, we're not doing that. Yep. So we now have this weird frosting. It's almost like that Take On Me music video now, but more Nintendo. Yep. Yep. So basically, using custom render passes, you can inject things and do lots of different cool stuff. I've got a couple more minutes. Do you want to see something that might break? Cool. So one thing I tried to do is lift the planar reflections from the boat attack demo and put it in here. And I got it working. Let's see if it's still working. So what I have here, let's turn off the screen because it's big and obnoxious. So in boat attack demo, we have basically a scripted render pass. Oh, it might break because it sometimes does this. So we have a custom render pass that's basically capturing the screen and then creating planar reflections for the water, all in real time, which is pretty cool. And as we know, Unity kind of doesn't have this out of the box. So what I decided to do is I pretty much lifted that script, commented out, used the namespace of water system, which is what Andre originally wrote, and then I set it to use a similar global texture that basically the other render pass was using. And let's see if this works. So I got the planar, even with the spelling mistake that someone wrote. Let's turn this on. So this is currently not doing anything. And then if I select this ground layer, I have a custom graphs, VFX, metal floor planar reflection graph. Let's see if this works. So we now have a planar reflection that's basically being projected. And you see it kind of doesn't work because it's kind of confused between the scene view and game view, if that makes sense. So maybe if I go into play mode, it would work. Nope. Usually if I close one. Why don't you work? Oh, OK, it's kind of fine now. So you notice here I've now got this kind of planar reflection that's taking place on the floor. It might be a little tricky to see. And as the character walks around and shoots, you can notice that planar reflection is taking place. Let's make this full screen. So we now have this character. Obviously, this was made for water. But yeah, we've got this all reflecting. And because the custom render pass outputs like this planar reflection texture in shader graph, you can kind of see this coming in. So we have planar reflection, which is kind of using the same system as the weird Virtual Boy effect. We have the result of the camera texture that's basically been output, and then I've put it through some reflection and different things. So you can actually see the preview directly in shader graph. So if you're an artist, you can say, hey, give me the planar reflection, and then you can do what you want with it and do all sorts of frosting and make it look weird, I don't know, do lots of cool stuff. So actually, let's brighten this up. So we now have this pretty cool effect here. And because I'm curious what is going to happen, let's turn back on that blur and the display, and let's see if it actually does a planar reflection pass and sort of, I guess. People won't know. It's OK. So yeah, that's using planar reflection pass with a custom sort of like red effect pass as well. So that's kind of something cool. I'm really happy that worked, actually. Yeah. I'm pretty much at the end of the talk. If I now switch to, I did that. So this is the thank you. This is the photo slide, I usually call it, where pretty much all the links that I referenced are here. Everything I did, you can do right now today. And if you go to this extending Lightweight Render Pipeline, I basically lifted that blurring directly from there. And the boat attacker lifted that planar reflections from there. So you can download these projects and download these links and kind of learn a bit more about it. We are still developing Lightweight Render Pipeline, so it'll be adding more different things and more performance and stuff like this in the future, and more features, but that's currently what you can do with it today. And it's already pretty cool that you can inject different render passes at various points and do stuff with it. I think that's pretty much the end of the talk. I'll be wandering around, so I'll be outside and I'll be downstairs in the expo and walking around. So come say hi if you're working on a project, I'd like to see it, or if you toy around with this, we'd like to know. There's also a forum thread for feedback directly to R&D. So if you want to give them feedback or have requests for things, send that to them. And I hope this was informative and was OK. Thanks for coming along, and have a good Unite Los Angeles.